welcome back to BiharGeeks. So today we are solving a very important question, that is diameter of a binary tree. This problem is frequently asked in FAANG and top tech interviews. So if you are new here, hit that like button and subscribe to the BiharGeeks for the more amazing coding content. Okay, let's start with the problem statement. So the problem statement here says that we have given a binary tree. Okay, so here is the root, and what we have to do, we have to find the diameter of the binary tree. So the diameter of a binary tree is the longest path between the two nodes. The path may or may not pass through the root. Okay, so in this example, as you see that it shows that the diameter is 3. Like we have three path from here. If we are counting like 4, 2, 1 and 3, in that case, how many lines are coming? 1, 2, 3. Okay, and for 5 case, 5, 2, 1, 3. So 1, 2, 3. In both case we are getting 3 only, so the maximum diameter of this binary tree is 3. Okay, if I move to the next question, so as we assuming that 1 and 2 only. Okay, 1 and 2. So in that case, we have only single line. So the diameter of this particular binary tree is only 1. Fine. And remember that the diameter measure in the term of the edges. Okay, not the nodes. As we see that the number of nodes are more in this case. Okay, we have to check this edges only, not the node count. Like if we're counting like node 1, 2, 3, 4, but you see that the diameter is 3 because we are counting the edges only, right? Now the approach we are talking about, so we will solve this problem using depth first search, that is in short we can call it like DFS, and recursion. Okay, in the step 1, we will find the height of left and right subtree of each node. And secondly, at the each node, we will update the maximum diameter as left plus right. Right? In the step 3, we will simply return the height, that 1 plus whatever the max is the left and right, we will return it. Now, let's jump to the code and we'll start in the Java. Okay, tree is already defined here, we just need to write the actual code here. So first we need a variable to store the maximum diameter. Okay, so int, put it int max diameter. Okay, and we will initialize as a 0 here. Okay, now what we need to find the we basically we will have a height here. Okay, using this height we will get to know whatever the diameter of that. So we will define the method here, height, and inside that we will pass it root here. Okay, and at last we just return the max diameter, and let me keep this outside this method, right? Let me copy this and keep it outside and make it as a private here. Fine. So this particular thing will be return the final computed max diameter, whatever we are getting from here, whatever the calculation we are going to do. Okay. Let me define the function here and keep it as private int height. Inside that we will need tree node and keep it name as node. Okay, so using this recursion function we will compute the height of each subtree, right? And here we will need a base case if maybe happen that a node is already empty. Okay, so in that case we just simply turn 0 from here, right? Now we need to recursively find the height of the left and the right subtree, right? So in that case, we need a left height, and that will equal to height node left, and same we have to do it for right. Dot GHD, right. Right. Now the next step is the we have to find the max diameter from here. So we'll keep it that max diameter here. Okay, and max diameter will be equal to whatever we get a max from here. Max, and inside that we'll pass the max diameter, comma the sum of the left and right. Sorry, right? And at last, what we have to do, we just simply need to return. Right, right. Okay, fine. So using that, what will happen? We will return the current node. Okay, current node, that is whatever we get the left and right from the height of the child. Okay. Uh, Right, let me run this. Okay, it's got accepted. Let me submit this. Okay, it's got submitted also. So here what is happening, let me tell you the step by step. So we have a tree node, okay, so which define the structure of a binary tree, which is already done here. Secondly, we have a diameter of a binary tree, okay, this one, the line number 18. So this calls the recursively function, that is height, which we have created, and it updates the diameter here, okay. And the height basically is the first, what we have done at the line number 24, we have given a base case, and secondly we will recursively call the height of the left and the right subtree, okay. Then we are updating the max diameter with the left and the right height, okay. And then lastly we return the max left and right tree plus with the addition of 1, okay, and which is giving us the height of the current node, okay. And finally it's done, and returning the result to us. And that if we talk about the time complexity, so the time complexity for this case is O of n, because n is the number of nodes, so each node is visited once, that's why the complexity of O of n. And if we are talking about the space complexity, so in this case, the space complexity will be O of h only, because h is the height of the tree. Because we are using the recursion, and due to recursion, it's giving us a O of h. Right? So that's it. We have solved the diameter of a binary tree with the complexity of O of n. Okay, and this is the high frequency code interview question. So make sure you understand it well, and let me know in the comment what's your favorite free problem. And don't forget to like and share and subscribe to Bihar Geeks for the more awesome coding content. Okay, so see you in the next video. Happy coding. Bye bye.